Hess's law states that the enthalpy change for an overall reaction can be calculated by adding the enthalpies for individual steps in the reaction. So here we have a reaction of X changing to Y and then Y changing to Z. So based on Hess's law, this is an overall reaction. But we can find the total enthalpy change for this overall reaction by adding the enthalpies for the individual steps. So here's, we're trying to find the change in enthalpy for the overall reaction, and then we have the change in enthalpy for the individual steps. X changing to Y and Y changing to Z. So by adding those together, we get the enthalpy change for the overall reaction. Now, Hess's law can be used for enthalpy changes for reactions that are either too slow or too difficult to measure in a laboratory. Hess's law can also be used for the enthalpy change for an individual step reaction, where you know the enthalpy changes of the overall reaction and the other step reactions. So I have an example of the use of Hess's law right here. In glycolysis, the series of chemical reactions that breaks down glucose in your body, glucose gets converted to fructose 1 and 6-biphosphate in 3 steps. And so I have those 3 steps right here. So with each step, we have reactants and then we have the products. And then I've written over here the change in enthalpy for each step. So all we have to do is just follow this up here to find the overall enthalpy. We just need to add these 3 changes in enthalpies of each step together. So we add negative 16.7 plus positive 1.7 plus negative 14.2. So when we've added all those together, I'll save you the math, we get negative 29.2, and then we just use the units that we've been using already, kilojoules over moles. So that's a practical example, a practical application of Hess's law. So remember that Hess's law says that the enthalpy change for an overall reaction can be calculated by adding the enthalpies for individual steps in that reaction.